Okay, good morning, class. I am not here today. I'm sick, but luckily I have the presentation set up for today's lesson so I can teach you guys virtually. Um, Today we're going to be beginning our periodic table unit. So we are going to start on how to understand the periodic table. My first question for everyone is what are elements? If you guys can give me a quick shout out of what elements are, name off a few. I'll give you guys a couple minutes, look at the substitute teacher, pick a couple students, and you guys share out your answers. Okay, awesome. I hope I heard some really good answers out there. I did pull up one example. I do have, I believe this is gold. This is going to be what gold looks like on the periodic table. It shows up as Ag, but its elemental name is gold, and it looks like that. Basically, elements are the smallest unit of matter that we have in our world. They are the simplest form of matter and they can no longer be broken down. So even though we have something really simple like water, water contains a couple different elements. You have hydrogen and you have oxygen in there. So that's considered a molecule. But if we took just oxygen and just hydrogen, those are two different elements. Each element has its own atomic number, elemental mass, and own set of characteristics. The atomic mass is basically how much a element weighs, 1 mole of an element weighs. The atomic mass accounts for the protons and the neutrons. So just the weight of the nucleus and not the electrons in the inside. An example of an element and how it looks like on the periodic table is going to be right here. We have neon. Again, this is how it looks like on the periodic table. We have its abbreviation, so Ne, its elemental name, which is neon, the atomic mass on the very bottom, which is the 20.180 grams per mole, and its atomic number, which is 10, and that's the placement of it on its on the periodic table. So we just went over that example, but let's go over it again. If you guys can all write this in your notebooks, along with the definitions of a element as well that we just went over. But let's take the neon as an example. If you guys can all write down what the atomic number is, the atomic mass, number of protons, number of neutrons, and number of electrons. Once we have that set into our notebooks, let's go over it as a class. What do we first see? We see its name, which is neon, and its abbreviation, which is Ne. The atomic mass, if we look at the very bottom, again, it's going to be that 20.180. That's going to be grams per mole. So a mole is a unit of measurement that we'll go on later into our units. But 1 mole of neon is going to weigh 20.180 grams. The number of protons. The number of protons can be found on its atomic number. So we have neon as 10 on the periodic table. So that means that there's 10 protons in one neon atom. Again, protons and electrons are going to be the same if it's not an isotope. So if it's standard elemental atomic form, the protons and the electrons will be the same. So from just the atomic number, we can find out that there is 10 protons in neon as well as 10 electrons. For the neutrons, from the atomic mass, we have 20.180. And what we're going to do is subtract the number of protons that we have. So the atomic mass accounts for what's just in the nucleus of an atom. So if we already know the number of protons in the atom that we found from the atomic number, we can then find the atomic mass. So if we do 20, we'll just keep it easy and leave it as a whole number. So 20 minus 10, 20 from the atomic mass, 10 is the number of protons, and then we should be getting 10 neutrons. And let's double check. Yep. So neon, again, atomic number is 10. The atomic mass is written down. number of protons is 10, as well as the number of electrons. And then by doing simple math, we found out that the number of neutrons in neon is going to be 10 as well. Okay, and let's do one more example. We have sodium. If you guys can just take a minute, write down all of that, and see if you guys can figure it out on your own. I'll give you guys a little bit, but whenever you're ready, hopefully the substitute teacher can unpause me and I'll show you the answers. So by following the same process that we had as well, we found the atomic number of sodium to be 11, the atomic mass to be 22.99 grams per mole. And from the atomic number, we found out there is 11 protons and 11 electrons. And for the number of neutrons, we'll take the atomic mass. However, I'm going to round this one up because I would like to keep it as a whole number. So from the 22.99, we'll round it to 23. And we'll do 23 minus 11, which is the number of protons. So 23 from the atomic mass minus 11 protons, and we get 12 neutrons. So a little quick, easy math. Mainly, all this will be given on the periodic table, and then the quick math from the atomic mass will be really easy. And you can find all that information just from one little block on the periodic table. So where can we find all 118 elements? In 1869, we had a really old scientist. His name was Dmitri Mendeleev, and he created a chart with columns and rows, categorized and organized for all the elements, and they're categorized by their characteristics as well as their atomic numbers and all the physical and chemical properties that we go into later on in chemistry. And that creates what we know as our periodic table. So it looks like this. As you can tell, it's a lot of different elements, and they each have their own characteristics, but they're all organized in a way that all scientists and chemists have learned to get all information just from one chart. So the periodic table is split and organized into groups, again, organized by those characteristics, and we'll go from one group to the next. So please write down notes on all these groups, because they're more than likely going to be on your test and homework for the next unit. And we have our first group. This is going to be right on the left-hand side of the periodic table. But before we go into that, let's go back and we're going to get a quick definition. So when I start using vocab words as groups and periods of a periodic table, that just tells you the direction of where I'm looking at. So a group on a periodic table is going to go up and down. It's going to be a column. So if we look on the first group, it should go from hydrogen down to francium. And then a period is going to be a cross. So it'll be a row. A period will be all the way from, if we look at the very, very top, hydrogen and helium, that's one period because they're all in the same row. So keeping those vocab words in mind, group is necessarily a column, and period is just a row. So let's go back. Our first group, the first column that we have is going to be alkali metals. These are going to be lithium, sodium, potassium, rhodium, calcium, and francium. Again, the first column, each of these are going to be highly reactive, water sensitive, soft, low density, low melting point, and a low boiling point. Again, write all these notes down, organize them, and keep them clean. Just that way we can get quick notes from each of our elements that we have on the periodic table. Our second group is going to be our alkaline earth metals. These are going to be strong reducing agents, silvery shiny metals, good conductors of electricity and heat, low density, low melting point, and low boiling point. These are going to be right next to the group 1. So if we just look to the next column, it'll be beryllium, magnesium, calcium, strontium, barium, and radium. You don't have to write each and every single element, because as you can see, the next group is there's a lot of elements for you to be written, but if you guys just know the location of each of the groups on the periodic table, then you'll be fine. Okay, so on to our next group. This is a big chunk. This one's not necessarily going to be a column, but rather we're going to categorize all these elements and keep them together, and just because they do have the same characteristics. So our next group is going to be the long portion of the periodic table. This is going to be the transition metals. Each of the transition metals have low ionization energies, high melting points, high boiling point, high conductivity of electricity and heat, and they are metallic and malleable. Okay, our fourth group of the periodic table is going to be metalloids. Most people tend to call this the staircase of the periodic table because, as you can see, it kind of looks like a little staircase. It's not necessarily a column, but it just is a little tiny group of elements that are very similar to each other. Each of these are semiconductors of electricity and heat. They have mixed properties between metals and nonmetals, more brittle than metals, less brittle than nonmetals, shiny or dull, and then ductile and malleable. Basically, they have the same exact characteristics as metals and nonmetals, but combined of each. Our next group is going to be our nonmetals. These are going to have high ionization energies, brittle and dull, poor conductors of electricity and heat, and they're going to be and they have low melting points. Our next group is going to be the halogens. It's going to be the second most right column of the periodic table. These are going to be highly reactive, high electronegativity, nonmetals, and they're toxic. This is going to include fluorine, chlorine, bromine, iodine, and acetine, I believe, if I pronounce that right. Okay. Our last group is going to be the noble gases, the very most right column of the periodic table. These are going to include helium, neon, argon, krypton, xenon, radon, and organoson. That's a long word, but it is there. They are going to be unreactive, nonmetals. Again, they're gases, low electronegativity, colorless and odorless, gases under standard conditions. So again, not metals, low boiling points, low melting points, and they have a complete valence shell, which we will talk about in next lesson, but that's an important note, so you guys can star that. That will be awesome. Okay. So besides all the different groups of the periodic table, the table tells us a lot more about the elements. We have periodic trends. Again, as the scientist who organized and created the periodic table, he put a lot of thought into it and organized it where each trend is not explicitly stated on the table, but it's so easy to know the characteristics of the element. So our first trend is going to be ionization energy, which is the amount of energy needed to remove the most loosely bound electron from a neutral gaseous atom. We'll talk about this in later units, but mainly all you need to know is that it increases across each period from left to right, and it decreases down a group. The next trend is going to be the atomic radius, which is the distance between the nuclei of an identical atom bonded together. So if we look, these would be two identical atoms, but it's just how far the nucleuses are from each other. So besides the shell of electrons, how far, and that is measured. So it decreases across a period, so it will decrease from left to right as we read, and it decreases down a group as well. Oh, I believe it increases. Let me see. No, it increases down a group. Awesome. So it decreases across a period and it increases down a group. The next trend is going to be electronegativity, which is a measure of an atom's attraction from electrons when bonded to another atom. This is basically how attractive an atom is and how much it wants to take or not want to take another atom's electrons, because electrons are shared amongst atoms, which we'll talk about in further lessons, but you would just need to know that it increases across a period and it decreases down a group. So I know that was a lot of information taken in, but now we know how to find information of an element from the periodic table just by looking at the little square it has. We know about the groups of the the groups of elements on the periodic table, as well as the periodic trends. But with all these notes that you guys have taken, we're going to start a little activity. Basically, I'm going to have this sub pass all you guys out a standard periodic table poster. Nothing should be colored. It should just be super, super blank. But I would like for you guys to split off into groups, design your own periodic tables based on the trends that we have, as well as all the groups that we have discussed before. So it should have the ionization energy, the atomic radius, and electronegativity trends, as well as all 8 groups that we just talked about, or 7 groups that we talked about. I do have a example one. I made mine here. As you can see, I made arrows describing the trends and where they increase and decrease, and I also color coordinated based on the groups as well. Each of the groups are labeled, and the trends are labeled as well, because each has their own way of increasing and decreasing. So split off into groups. Each of you guys will make a poster. We'll later present this in class. When I'm late, I'll have you guys present when I'm back in class. But make little notes about each of the groups that we have, what each trend means as well, because we'll be using these later on in class, and they'll help you guys out for a test later on. But in your groups, just make little descriptions and make the poster look really nice. Again, when I come back, we will present all of our findings and observations about the groups and trends about our posters to the class and to me, so I can make sure that everything feels okay with you guys, and if we need to go over anything as well. I will have the substitute pass out worksheets. You guys should be getting those right now. This is going to have questions about the periodic table and trends that we just went over. If you guys need help, look back at your notes. But complete this for the rest of the class. After you guys finish your group projects. But if you don't finish your worksheets, don't worry about it. Complete them for homework. And if you find yourself at home, have questions or just concerns about the information that we went over, circle the problems, and then we'll go back to it when I come back in class. That way I can make sure that each and every one of you really understands this as well. Okay. But for the end of the day, just finish that group project really quick. Again, it doesn't have to be super, super fancy. Just make sure it looks really nice and pretty. But each of the groups are color coordinated, and they have their names and labels and quick descriptive words. But before you guys leave, if you guys can please complete your exit ticket. Today we'll have it as a Kahoot quiz. I have the substitute teacher loaded with her quiz as well. They're going to be really, really short questions and answers. I'm not going to be grading based on the correct answers, but I just need to make sure you guys participate, and that allows me to know who and who wasn't here in class when I wasn't here. And then the top 3 winners of Kahoot, I'll give you guys extra credit as well on your worksheet packets. But if you guys have any questions, please email me. I am not here right now, but I'll make sure to email you guys as fast as possible. And I'll talk to you guys the next time I see you.